Hey guys, well, in this video, I'm going to show you how to do integrals in this video. Now, if you don't know already, derivatives and integrals are inverses of each other, at least the formula on how to get them. Integrals is the area underneath the curve on a graph, and derivatives, which you learned beforehand, is the instantaneous rate of change on a slope. So we're going to do integrals, but I'm going to show you how to do it by solving a derivative first, because the proper way of learning calculus is you do derivatives first and then you learn integrals. It's just easier that way because it's just easier to present that way. Okay, guys? So I'm going to show you how to do derivatives first. So these two questions here are inverses of each other. We're going to get the derivative of the bottom equation here, which is 4x to the power 5 plus 4x cubed plus x squared plus c. Let's just say that we have a number of 8.5. So we're going to say we have an equation, a function of we're going to have a function of f of x to the power of 5 plus 4x cubed plus x squared plus 8.5. Okay, so that is our function. It really doesn't matter. This is a constant. If you get the derivative, I think the constant always equals out to 0, so it just disappears. So that's why I just put a random number there. But normally, but when you do the integrals, you put the c in the end because you don't know what the constant is, because it doesn't matter for integrals, but it does matter for the when you go back to the original form from using the integral method. So when you go to get the derivative, the constant at the end disappears, but when you go back and do the integrals, the opposite, you have to add at the end that there is a constant at the end that we don't know of. Okay, so that we can find the constant if we know some coordinate points on the graph, but I'm not going to cover in this video. We will maybe do that in the next video, but in this one, we are going to show you how to do the integral so that you are going to get left with a beautiful constant at the end, okay? So that's how we're going to do this, right? So we have a function. So how do we get the derivative of this? If you guys don't already know, we just take the 5. We take the 5 at the end, right? And then we multiply 5 to the constant, so it becomes 20x. So 4 times 5 is 20, and then you take 1 out, subtract minus 1 from the power, okay? So, or the exponent, okay? So 5 minus 1 becomes 4. And then plus 3 times 4 is 12, so we have 12x. 3 minus 1 is 2, so 12x squared. Plus, we have a constant here of 1, so we do 2 times 1, which is 2x, and then 2 minus 1 for the exponent here is 2 minus 1 equals 1, and then the constant, and then we're not going to write the 1 because obviously it's assumed, and the constant disappears because, you know, technically if we have a x to the power of 0, which would be 1, we multiply 0 by 8.5, that becomes 0, and then if you multiply, so it becomes 0 times x to the power of negative 1, but 0 times anything is 0, so we have 0, okay? So that's the basics of how this works. Okay, so that's how we're going to do this. Now we have 20 to the power of 4 plus 12x squared plus 2x. Okay, so now to get the derivative, now after this question, I'm going to do a little bit more challenging one, which is going to be a little confusing, but you will have to do it to pass your examinations and get your A's and B's on your university college grads. Okay, guys, look. This is the easiest mathematics you will ever do today, okay? So to the integral, so this is what we have here at the top. So to the integrals, we have this F sign. It's not from band, it's not from symphony or music. It's not the I don't know what the symbol is, but they use that in music as well, like at the on the left side of most of music. I don't know, like you know, look. It's a beautiful F. You see it everywhere, okay? So, and then we have dx, okay? So we have a dx on the right side, okay, here. That's how this works, guys. I used to be in high school band. I was a nerd back then, but I'm still a nerd. Doesn't matter. So, guys, look. We have the integral. So we have a integral. To do the integral sign, you put the f and the dx on the outside, and they wrap it around. So this is what you're finding the integral of, guys, in the middle. Okay, so guys, look. To do the integral, you add 1 back to the constant. So x. So and then you divide that to the constant. So 20. And so this is how I do it. So 20 times x. 4 plus 1 is 5, and then you divide the constant by 5. The next one is 12 divided by 12 times x. 2 plus 1 is 3, and then 12 divided by 3. So that will be 4. So we have a 4 right there, right? And then the next one will be 2 times x, and we have a 1 here. So we have technically a 1 here, right? We don't write it, so we have a 1. So we're going to do 1 plus 1 equals 2, and then we're going to divide that by 2, and we add in the constant. Remember this? We disappeared this 8.5. Well, it comes back. We don't know if it's 8.5 unless we have some coordinates to type in and then to plug in and actually get the function. We don't know how to do that yet, right? So we had to play. We have to put a beautiful constant there. C for constant. Okay, guys? C for a beautiful constant. Let me just write that C beautifully one time. C for a beautiful constant. Okay, that's how it works. Okay, guys. So now let's do some algebra. It will be 4x to the power of 5, right? 20 divided by 5 is 4. So 20 divided by 5 is 4 plus 4x cubed plus x squared plus c. So that is our answer. Now we have 4x to the power of 5 plus 4 to the x cubed plus x squared plus c. So that is how we do integrals. So that is the basis of it. Now let's do a little bit more challenging problem before I let you guys off the hook. We are going to do one that's going to instigate you into thinking, why am I in calculus class? Okay, guys, look. We have this too. These are the integrals. Now, this is the answer we're going for. And this is the integral that we are doing, okay? So these are the inverse of each other, okay? Guys, so this is a little bit challenging because I fumbled in the powers and just made it a little bit confused, okay, guys? So so the integral that we're solving for is this bottom one, second equation here, this right here. Don't ever take your eyes off this question. You will solve this calculus equation with me, okay, guys? All right. So 8x to the power of 15 over 6. Now that will be divide top and bottom by 3 will be power to the 5 over 2. I just made it a little bit confusing, just on purpose. So you might want to do that first. Then we have 4 to the x to the power of negative 1/2 plus 3 to the power of x to the power of negative 8. Okay, guys, that's what we are solving for, okay? Now, I am not a professional, but I do know how to solve this integral. So we have, just to rewrite it out, we have the integral of, now this is a horrible F, but I'm just going to do it, 8x to the power of 5 over 2 plus 4x to the power of negative half plus 3x to the power of 8. And we just do a dx there. And we're going to have a constant at the end. It can be any variable. We're just going to put a c for now because this is what we're going to do. Okay, guys? We're going to do this. We're having a good time solving this math problem. Okay, guys? To keep on with the previous pattern, we do 8 times x and we add 1. So we add a plus 2 over 2, which is power to the 7 over 2. And we divide that 8 by 7 over 2. That's how this works. Okay? So 4 times x, negative 1 plus 2 over 2 would be positive 1 over 2. And we divide that 4 by 1/2. And then we have 3 times x, negative 8 plus 1 is negative 7. And we do negative 7 down here, divide by negative 7. And then we add a constant at the end. Remember this constant, don't forget it. Don't forget the constant. Okay, now that we've done that, we are going to move on and we're going to actually solve this, okay? So we have 8 times divide by 7, 2 is equal to multiply by 2 over 7 times x to the power of 7 over 2. Divide by 2 is basically multiply by 2. So we have 8x to the power of negative half. I'm sorry, power of 1/2 plus. And then we have 3 over negative 7 to the power of negative 7 plus our constant c. So that's how this works, guys, okay? We gotta work it together. Keep it together, guys. So we are going to do 16 over 7. So remember we have 16 over 7 here, over here, right here, guys. We are going to have that right here, guys. Okay, guys, look. Focus, 16 over 7. Times x to the power of 7 over 2 plus 8 to the power of root of x, right? 1/2 power is same as square root, so we have square root x. I believe that's what we have here. Square root, I didn't write root x there, but anyways, we have then 3 over negative 7 times x to the power of 7, right? Because if you have a negative exponent, it goes to the bottom of the denominator, into the denominator. So we have plus 3 over negative 7 times x to the power of 7 plus 7. That's how we do this, guys, okay? That's how I would do it. No, that's how Isaac Newton would have done it when he was discovering calculus integrals the first time, all right? And Leibniz, I forgot the other guy who co-discovered calculus, but I think it was Isaac Newton. My math history is not that great, but you know, one of the greats of the greats. He was a polymath, studying math, physics, and chemistry, and about. I think that's what it was. You know, guys, let's focus. Math is amazing, right? So we are going to do 16 over 7. I mean that is the answer, guys. Look, 16 over 7, right? Times x to the power of 7 over 2 plus 8x to the 8 times square root of x, right? And then negative 3 over negative 7 multiplied by x to the power of 7 plus c. So that is the answer of how you can do integrals and derivatives. I'm sorry, guys, if this class was boring, this lesson was boring, I hope I made math a little bit less boring for you. If not, give it a downvote. If I did make you happy, please study more math. I do deserve no recognition. I just want you to pass your calculus so you can be an engineer and be a focus of society like Elon Musk or any of the other greats who had done a lot of STEM engineering and business in our country. Or USA. By the way, Elon Musk is Canadian. Anyways, guys, look. I just want to say thanks so much for watching the video. I hope you guys have an amazing time learning calculus. I'm trying to get good at calculus right now. Hopefully I can make more videos for you guys. I'm working very hard to get good at math. Hope you guys leave a like and a subscribe if you don't mind. And I'm going to continue making more math videos. Have an enjoyable day. I will see you guys next time. Signing out, guys. Bye, mathematicians. Peace. Bye.